And go.
All right, so I'm Kyle.
My name is Jay. And I'm Richard. And our project is an alarm clock system that also has an EEG reader attached to be able to wake you up earlier if, say, that you're in a light area of your sleep cycle. So if you want to come over here and look, that we have a real-time clock enabled on our system that is it's very accurate. It's accurate within less than 1%. So over a 24-hour period, it ended up only being off by like 10 seconds, but that again that's mostly offset by the fact that we won't let you set the seconds in the system, so it'll always default to 0. So if you're past a minute in the area, it won't let you. So this is the EEG reader. You want to?
Sure, yeah.
Kyle, do you want to demonstrate putting this on for us?
Yeah, sure.
Beautiful.
So this is the EEG headset. This is actually from a toy game by like Mattel Toys. They have a toy that you can use to control some sort of game with your mind. We basically bought one of these off eBay for $25, and we hooked up these 2 wires to a data channel and are able to read UART data from it into our PIC32. It's just serial data. It gives you a packet every second, and it contains information about signal quality as far as what it's reading from your brain. It gives you an attention value, a meditation value, and 8 different frequency band intensities. So we were able to read this data off of this headset using the UART functions on the PIC32, and we were able to use those frequency intensities that I just mentioned to determine if you were in a light sleep state, theoretically. So what you actually just heard is, if you can see here,
So
the alarm is set to 8:45, and it's now 8:40. What it picked up is the fact that I'm awake. So
Okay.
it went off
So
early.
it'll turn on earlier. It'll turn on within like 30 minutes early of the actual alarm being on if you're in a light sleep cycle.
It'll begin detecting 30 minutes before the alarm, and then if it finds that you're in a light sleep state, it'll wake you up.
Okay.
So basically, to do that, there's a certain frequency band called alpha waves, and when you enter your lighter sleep states, these begin to peak. So what we look for is 10 peaks in that 30 minutes of alpha waves of frequency bands up above a certain intensity value that we determine to be indicating that you are in a light sleep or an awake state. And I tested this last night, and it did wake me up early, and I did feel pretty good. So it seems to be working pretty well.
Okay.
Do we have other features we want to talk about?
So it defaults to like 11:59 p.m. So on your first startup, it'll let you the real-time clock. We have options for letting you set up the real-time clock to whatever time it is exactly right now, and the alarm also it'll all turn like the real-time clock. It just.
I mean, so you could show how you
Yeah.
set either the alarm and also the actual time.
It's basically just like a
So
clock.
I'm just going to reset it and then show you what the default time is. So when you restart it, it defaults to 11:59 p.m., which in the real-time clock is saved as binary coded decimal. So I actually just read the data from the real-time clock gives you, and then converted it from its binary coded decimal form to the actual binary representation. So 12 a.m. is actually 0 because of how it goes. It goes 0 to 23. So if you want to set the time, I'll just show an example. So at 2:23, when you hit set time, this is like our debugging mode. When you hit set time, it'll go to 2 hours, 23 minutes, and then it'll start counting. PM has the same feature, where it'll go to 14:23.
The alarm works similar. So
The alarm uses the same.
right now it's set to 11:30. And you can see if we set that to 1:30 a.m., it'll show you up here, and it also says alarm disabled if we want to turn it on. Just give it a tap, and that's enabled.
Hopefully this will eventually focus.
Oh, sorry, you didn't see that.
I saw the tab, but I can't read any of the font,
Okay.
the small stuff. But okay, now I can sort of. Yep.
Also, we have a dimming function Right now, we developed it in parallel with the real-time clock system, and they both seem to use one of the same like pin connections. So when we do connect it, it does the dimming correctly, but the issue that we have with it is that it's getting another signal at the same time. So as it sets, it will set to 0, and then it gets another some other thing is giving it information, and it goes back to, because
There seems to be some sort of.
so it blinks. So what happens is the dimming, it has the dimming
Goes down.
PWM, and then it's getting some other random value
Okay.
for a certain amount of time, and when it gets like a random value, it just goes to on. Just
Okay.
100%.
This works without the other features enabled, but for some reason we didn't have enough
Okay.
time. To
So
figure out
we
exactly
do.
why.
We want to show you on the other one. We have a previous version of the code that doesn't have the real-time clock stuff enabled.
Okay.
That it works on really well. If you want to,
Alright, so
there's 5 different.
there are 4
dims.
different settings.
4 different.
Yeah, this
Okay.
is first, second, third, and fourth.
Oh, okay.
So whatever the real-time clock.
Yeah, the real-time
it's-
clock.
It's interfering with this.
We have to
PWM.
spend more time with it, but like I've tried different. I originally tried different output compares that didn't seem to be doing it. I tried different timers. I'm not really. It just has to be something that it's used. It's getting. It's just getting sent information by multiple threads,
Mhm.
and
Okay.
we haven't been able to figure out